So example 1 says, suppose f of x and g of x are functions of x that are differentiable at x is equal to 3, and that f of 3 is equal to -1, f prime of 3 is 5, g of 3 is 1, and g prime of 3 is equal to 2. Find the values of the following derivatives at x is equal to 3. So I'm going to take the derivative of what's inside the parentheses here. I have f of x times g of x, so I'm going to use my good friend number 1, the product rule. So we have f of x times g prime of x plus g of x times f prime of x. And then on the second part here, I'm going to do the product rule again with -6 as my first term times the derivative of f of x, so times f prime of x. And then the second part of that would be 0 because the derivative of my constant there is 0. Okay? So now x is equal to 3, so I'm going to plug in 3. So I got f of 3 times g prime of 3 plus g of 3 times f prime of 3 minus 6 times f prime of 3.
Can you repeat what you were saying about the whole constant thing? What would be 0?
Sure. There are two ways to think about the derivative of -6 f of x. Okay. If I do the product rule, where -6 is my first term and f of x is my second term, I would have -6 times f prime of x plus 0 because the derivative of -6 is 0. Or anytime you have a constant there in front of it, you can just bring it down and then take the derivative of the second part. Now I need to evaluate all these. So f of 3 is -1 times g prime of 3, which is 2, plus g of 3, which is 1, times f prime of 3, which is 5, minus 6 times f prime of 3, and f prime of 3 was 5. So now it's all over but the arithmetic. I've got -2 plus 5, which is 3, and 3 minus 30 gives me -27.
Hold on in a minute.
Take your time.
I understand this.
Any questions there on that first one? Well, why don't you try the second one? I'm taking the derivative. I probably should have put in some x's in there. So I've got g of x divided by f of x. So I need to use my good friend number 2, the quotient rule. So go ahead and do that for me, please. Why don't you check your answer there with your friendly neighbor? Okay, so you should have that
3,
for your derivative.
1,
F of x times g prime of x minus g of x times f prime of x over f of x squared. F of 3 is -1 times g prime of 3, which is 2, minus g of 3, which is 1, times f prime of 3, which is 5. So let's see, that's going to give me -2 minus 5 in the numerator, so -7. And then f of 3 was -1. So I'm going to have a -1 squared, which gives me -7 over 1 for a grand total of -7. That's what you should have got.
Wait, hold on. I need a minute. I'm really lost. So you don't plug in the 3 at all anymore?
Yes, I did. I just skipped a step. I can go back and plug it in, but I just looked at all of these are all 3s. So I just wrote down the values of f of 3 and g prime of 3 and so on.
Oh, I see what I did wrong.
Okay. Questions on any of the first 2 examples there? All righty then. Example 2. Suppose functions f of x and g of x and their derivatives have the following values at x is equal to 0 and x is equal to 2. Evaluate the derivative of. Okay, so I see these problems a lot on the AP exam. They're fairly common when they ask you to differentiate, and then you've got to look at a chart or maybe a graph over here or something like that. So let's take the derivative. I have 9 times f of x. So doing the product rule, that's going to be 9 times f prime of x. And then the second part of that is 0 because the derivative of 9 is the constant. What's my derivative of g of 2x? It will be g prime. Bring down the 2x. And then multiply times 2. The derivative of 2x. The chocolate there. Okay, so now I'm going to plug in 0.
Oh, I did that, but I got the wrong numbers. 90%.
So I have 9 times f prime of 0, and I'm going to go to my chart and find f prime of 0, which is -2. So that will give me 9 times -2 plus g prime of 0 is 5 times 2.
Attendance, please.
So I have -18 plus 10. So you should have gotten -8 for this one. So take a look at that one. Make sure that everything makes sense for that. And anything I can answer for you about that one? Everything okay?
You didn't use the product rule on g times 2x,
Not on this because
but
it's kind of like a composite function. Okay, so when we're taking the derivative of a composite function, it's going to be the derivative of g, so g prime. The 2x comes down, and then I multiply by the derivative of what's inside the parentheses there, which in this case is 2. All right. Here we go. I have the square root of f of x. So my first step would be to rewrite this. How am I going to rewrite it?
F of x 1/2.
All right, I like it. F of x to the 1/2. Now what?
Do the rule,
What rule is that?
the power rule, but the composite rule at the same time.
The chain rule. There we we go. Now we are talking. Gonna use my go for number 3, the chain rule. So the 1/2 comes up front. F of x comes down. Now what?
Now you wanna do,
Now subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Now what? Multiply by the derivative of what's inside there, which is f prime of x.
see, this is where it gets weird for me. There's like 2 ways, you know, for the chain rule. There's this one, and then there's the one we just did. You know what I'm talking about?
I do. Okay, so here's the difference. Anytime you have an exponent here, you're going to do the chain rule where the exponent comes up front, the function comes down, you subtract 1 from the exponent, and then you multiply by the derivative.
Yeah.
And then if it looks like this is a composite function. So let me leave that one for just a second and finish this one out. I'm going to plug in 2 here. So that's going to give me 1/2.
Wait,
And
so,
then f of 2 raised to the negative 1/2 times f prime of 2. So all I did there, since x is evaluated at 2, is I took 2 and substituted it in for x. And now I need to plug in some values here. So what is f of 2? I'm going to look at my chart, and f of 2 is 4. So that's going to give me 1/2 4 to the negative 1/2 times f prime of 2, which is pi. And so now what do I do with the negative exponents?
you gotta flip it over 1 and square root it.
Okay, so you're saying if I have the negative exponent, I move it to the bottom and it becomes positive. So it'd be 1 over 4 to the 1/2, which is 1 over the square root of 4, which is 1 over 2. So I have 1/2 times 1/2 times pi. 1/2 times 1/2 is 1/4. 1/4 times pi. It's going to give me pi over 4 for my answer there.
We don't change the
No, I would leave it.
Where do you get the 2/2 from? 1/2 times 1/2.
I got it from 4 raised to the negative 1/2. So 4 raised to the negative 1/2 I read is 1 over 4 to the 1/2, which is 1 over the square root of 4, which is 1/2. So
Oh.
this right there replaces that.
Oh, okay.
There's so many ways to just write one number.
So
All right, so now,
Is A?
Jacob,
Is
to,
Is A just a composite function though? Is that pretty much what it is? Like pretty much, you know?
well, it's the product rule, and then this is a composite
Yeah,
function,
okay, yeah.
yes. So this is also a composite function, but there's no numbers right now. So if we're doing the function notation here, we've already did this, like when we did the chain rule notes, the derivative of this is always f prime. Then I bring down the g of x, and then I multiply by the derivative of what's inside there, which is g prime of x. And so I'm going to evaluate this at x is equal to 2. So that's going to give me f prime g of 2 times g prime of 2. And you should work from the inside out here. G of 2, looking at my chart here, g of 2 is 2. So that will give me f prime of 2 times g prime of 2. And f prime of 2, looking at my chart, is pi. And g prime of 2, looking at my chart, is negative 1, which gives me an answer of negative pi for the final answer. All right, and so on this last one, there's a little typo there. I want this to say, I want the f of x to be in brackets there. So I want this as 1 over f of x squared. So anytime I have a situation like this, I want to rewrite it. So I'm going to move the exponent to the top and change the sign. So this would be f of x raised to the -2. And now I'm going to use my good friend number 3, the chain rule, to find the derivative.
All right, let me do it for a second. Hold on.
Okay. Don't watch.
I did it.
-2 goes out front. F of x comes down. I subtract 1, which gives me -3 for the exponent. I multiply by f prime of x. Now I'm going to plug in 0. So that will give me -2 f of 0 raised to the -3 times f prime of 0. Now I need to look at the chart to evaluate. So f of 0 is 1. Okay, so that's going to give me -2 times 1 to the -3 times f prime of 0. And f prime of 0 is -2. So now anything, when we have 1 raised to any exponent, it is always just 1. So I have -2 times 1, which is -2. And then -2 times -2 gives me +4.
No. Right. Mr. Newhouse. No, you have the wrong number. Sorry.
Can you remind me of like, whenever it is a negative exponent, what do you do? Like if it was like 4 to the power -2?
Sure. So if anytime I move an exponent, I'm going to change the sign. Okay. So if I have something like a function f of x raised to the -4, and it's just like f of x to the -4, I'm going to write that as 1 over f of x to the +4. So I move it to the denominator and I change the sign.
Right.
If it's in the denominator, I can move it to the numerator and change the sign also. All right, well, the next problem here, yes,
So
question.
so when applying the before exponent to what's in brackets, is there ever, like, does the negative sign change anything about that, other than the fact that it became a denominator? So like, say if it was not 2 or not 1 and it was 2, would the negative part of the exponent have change anything about?
I guess I'm still confused about what you're asking me.
So like,
Can
if it
you?
was 2 to the -4.
Okay, so I have 2 to the -4.
Would you just do it like if it
That would
was
be 1 over 2 to the 4th.
Okay, so that would just not meaning like that, but like just does the negative, if it's in the numerator, does it apply, like the negative signs that apply to the whole number? So like instead of it being, okay, never mind.
No, keep going.
Never mind, I think I figured it out.
Are you talking about like that?
Yeah, would it ever like apply to like the whole number?
If it's inside parentheses, then yes. Okay, if it's not, then no. Does that answer your question? Okay. All right, now we're going to look at the next question, which is excellent.
RSA.
Excellent. Let R of x equal f of g of x and s of x equal g of f of x, where f and g are shown in the figure. And part A says find f prime of 1. So I want the derivative of R. And R is f of g of x. So I'm going to use my composite function notation derivative there, which is f prime, bring down the g of x times g prime of x. This is something that you should know going forward, okay? Anytime you have the f of g of x, the derivative is always going to be in this form. So now I'm going to evaluate it at 1. So I have f prime g of 1 times g prime of 1. And now they do not give me these values. They give me a chart and ask me to interpret them. All right, so I need g of 1. So go to your g line. And when x is 1, y is 4. So that's going to leave me with f prime of 4 times g prime of 1. So how do I get f prime of 4? I'm going to go to my graph and find the slope of the f line at 4, which is the slope of this line segment here. So starting at the point 2, 0, I'm going to go up 1, 2, 3, 4, 5, and over 4. So that is 5/4. But that really does not matter. Why does it not matter? The other slope, what is g prime of 1? G prime of 1 is the horizontal line there, which is 0. Therefore, the value here is going to be 0. All right, why don't you try the next one? We want s prime of 4. So try that one for me, please.
I got you. A little slow. Why not go slow?
Check your work. I'm up to right here. I have s prime of 4. It's g prime of f of 4 times f prime of 4.
What's f of 4?
That is a good question. What is f of 4? I would say it's probably 2.5. So then we got g prime of 2.5 times f prime of 4. And I just did f prime of 4. It was 5/4. So now I just need g prime of 2.5. So the derivative at 2.5 is the line segment here, going up 2 and over 4. So the slope there is 1/2. Now, in my last period, I made some joke about doing all this calculus and then it comes to a grinding halt because we can't multiply fractions. It turned out it wasn't a joke.
I can.
There was some serious debate on how do you multiply fractions. So help me out here. How do we multiply the fractions? So 1 times 5 is 5. 2 times 4 is 8. That's all you do? That's all you do. Final answer of 5/8. Okay? Any questions for me on that one? We're almost there. I'm about to hand off the baton here, let you sprint to the finish. Come on, we got 2 more. So part A.
Wait, we missed one.
Oh, Jacob.
Oh,
I was just about to skip an entire problem there, and you have rescued me. I do appreciate you pointing out the fact that your teacher skipped a whole problem on the notes. I mean, I probably would have picked one on the quiz just like that one, right? And then you find people would have been in trouble. So thank you. Here we go. I want the derivative of h of x. So h prime of x. I want to do the product rule. So x times f prime of x plus f of x times 1. And now I need the derivative of g of 3x minus 2, which is what?
G prime.
G
of-
prime. Hold on, slow down. G prime.
Of 3x minus 2
3x minus 2
times.
times,
Derivative of 3x minus 2.
which is
3. Yeah.
Got it. Now let's plug in 1. So h prime of 1 is going to be 1 times f prime of 1 plus f of 1 plus g prime. If I plug in 1, I got 3 minus 2, so that gives me 1 times 3. Okay, so now look at the graphs. What is f prime of 1?
1.
Negative 1 there. So I've got 1 times negative 1 plus, what's f of 1? 1 plus, what is g prime of 1? It's 0. I'm looking at the slope at 1. So the times 3 doesn't matter there. So I've got negative 1 plus 0. I did all that work and end up with an answer of 0. Well, do you have a question? Raj?
I just got lost.
Okay,
I don't know.
from here to here or
I think the second part.
right here?
No.
Right here.
Yeah.
Okay, so I plugged in 1. So that gives me 1 times f prime of 1 plus f of 1 plus g prime of 1. And then you're going to go to the chart and evaluate all of these. So f prime of 1, I'm looking at the slope, which was negative 1. F of 1 is just the value of the graph of f at 1, which was also 1. And then g prime of 1 is the slope of g at 1, which was 0. So I've got negative 1 times negative 1 plus 1 plus 0, which is 0. Yes.
So you know in the first step for, so how do you get the derivative of x of f of x?
I did the product rule between those two terms. There's two terms.
And then so for the first part it would be x times f prime of x and then plus
F of x times the derivative of x, which is 1.
wouldn't it be, but isn't x 1? So the derivative would be 0. Or
If there were a constant there, then the derivative would be 0. But there's a variable there.
So take the exponent.
What's the derivative of 1x?
1.
Okay. All right, 2 more.
Wait, how come you didn't plug in the 1 for 3x minus 2?
He did.
I did. So when I plug in 1, I have 3 minus 2, which is 1. So that gives me g prime of 1. Make sense? All right. Okie dokie. Find the derivative of f of g of 3x at x is equal to 1 for the functions f and g in the table. So here I'm going to use my composite derivative. So that's going to give me f prime. And then the g of 3x comes down. And then I multiply by the derivative. So g prime of 3x times
Three.
3. The chocolate there.
That was the
Technically, if it's just that, then semantics, right? There's a 3 there. All right, so now I'm going to plug in 1. So that will give me f prime g of 3 times g prime of 3 times 3. And now I'm going to go to my chart here. So g of 3 is going to be 2. So that's going to give me f prime of 2 times g prime of 3 times 3. F prime of 2 is -3. G prime of 3 is going to be 6. So I have -3 times 6 times 3, which is -18 times 3, which is -54. Woo. Now I'm going to hand off the baton to you and let you finish the calculus race here. So let's go. Finish it up for me. The last one. Work that last problem. First step is up there on the board.
Yeah.
And I'm going to plug in 1 and go to the chart to evaluate. F of 1 was 4, so that's going to give me g prime of 4 times f prime of 1 times 2. G prime of 4 was 1. F prime of 1 was -2. So I have 1 times -2 times 2 for a grand total there of -4 is what I got.
I know how to do that.
All right.